Okay, hello YouTube. Giving you guys a quick update. I'm actually making wiring right now for my experiment. I had a few posts since my last update online. A few people were concerned that somehow or another a capacitor in a parallel setting and series setting to a battery bank could possibly result in it shorting out. A few of you have also said that it could charge to the maximum potential of the bank. And a few of you have said the experiment won't work. So just looking at this thing, I wanted you guys to get that quick update before I actually finish making the cables and coupling everything together. I have my safety equipment around me, fire extinguisher, goggles, all those good things. In the likely event that this does fail, basically the capacitors would blow if I were to wire it in 48 volts and it were to charge all the way to 48 volts. So what I'm doing instead is I'm running a bench test, and I'm running, instead of 4 batteries in parallel to this bank, I'm actually going to split this into 2. I'm going to have 2 27 DC2 type batteries tied up in series for 24 volts, and I'll have a battery and a supercapacitor wired up as a separate bank in series, and I'll parallel those two together and put a load on it to see what the behavior is for the capacitor. My theory still is that the capacitor will keep the charge of the battery bank and take less of a hit on the actual battery. So that's where I'm at. Pausing the video until I can get these cables connected, and I'll let you guys see how it works. Just so you guys can see, right now I'm at 11.8 volts for the capacitor, and we'll test the other batteries, see where they're at. We're at keep both these on here at the same time. We're at 12.1 on the battery. On the set of batteries, the 24 volt bank, we're reading, this is a more difficult one than I thought. We're reading at, let's see here, 24.7 volts. And because I keep moving my hand, 24.7 volts, you guys can see. Just have this bank wired up in 24 volt. Okay, making my tied connections. Now, being that this capacitor will be directly wired, it's likely that this 12 volt battery will charge the capacitor, and both will be the same, just because they're in parallel. So nothing new there. I'm gonna pause while I connect those. So you guys can see, I have hooked the battery and the capacitor up in parallel temporarily and charged them both to the same. And currently I have the positive from the capacitor hooked up to the negative of the battery. And this connection should give me, between the negative pulse of the capacitor and the positive pulse of the battery, it should give me 24 volts. Let's see what it gives me. Okay, might help if I set the digital readout here. Man, this is more difficult. Need a tripod. Okay. So, negative here and positive here. Okay, so see what we get here. We get 24 volts. Most shy of 24. Okay, we're getting there now. Alright. So far, battery capacitor wired in series produces 24 volts. So far, theory is awesome, and it works. Now, I'm going to connect this bank with that bank in parallel. Let's see what happens. I'm leaving the camera on this time so you guys can hear. getting 24 volts out of the battery and the capacitor. Now I'm hooking up the battery far away. Not anything likely to happen, but let's see here. Now I have that hooked up. We're still doing about 24 volts. So, concept proven. A capacitor hooked up in parallel and in series will act as a battery. And with that being said, it will work with the 24 volt. But I'm going to go ahead and give you guys the voltage of the capacitor. Here. Capacitor. Get the connections back here. Alright. The capacitor's voltage 11.9. Lost a little bit, probably with those sparks I did a few seconds ago. But yeah, it works. So if I'm charging, going to the capacitor, it'll translate over to charge to the batteries at the same time. Awesome. Hello YouTube, quick update. Just proven that you can use a supercapacitor as a battery to help in driving the load of an inverter. Cool thing here, I did prove it with 24 volts, but 48 volts should be the same. The supercapacitor holds its value at 12 volts as a battery and continues to work as a battery in the series. Now, as the inverter draws power, the supercap will be drained first, but because of the amount of farads it has, and the complete series that I have is 2600 farads times 2 capacitors at 15 volts, you have somewhere around 5200 farads of workable power. I know it's a little less than that with the actual math behind it, but when it comes down to it, it's a really good concept because you know, if an inverter's pulling 100 amps, it'll draw it directly from the supercaps, and then the supercaps will slowly draw their voltage back into the capacitor, which in turn means that a compressor coming on with a large load of 400 amps for 10 seconds will draw the capacitor first. And as the voltage levels out, by the time that it does, the batteries will have had the supercap right back where it needs to be without damaging the cap. So, something new, something for a few of you YouTubers to try. I'd like to see more theories on how it could work in other alternative systems, but the way I have it, it looks pretty good. FYI, I saw a post from one of the people on my last video for supercaps. That basically, drawing from the screen here, so don't mind it. That says that basically, you know, the power comes from the negative side, and you would be not absolutely correct on that. So here's where it actually breaks down. Alright, so battery in a circuit provides electrons to go to a device, usually through some type of switch, to complete a circuit. Well, the electrons are actually leaving the battery. Electrons, as you know, are negative. Now, the reason that we fuse the positive side of the battery is because as the electrons leave, they actually leave the positive side. Now, probably that doesn't make any sense, but if you think about it, you're draining electrons from the battery. So, as they're leaving, you're negativing a negative. And in turn, you're taking electrons away from the battery. That's where the power comes in, which is, like I said, why you always fuse it on the positive side, because that's where the electrons are coming from. If you've ever touched a battery, you'll also notice that the end that gets hot is actually the positive end. So, something to kind of educate that one person about, but Other than that, that's why I have my supercapacitor hooked up to the positive of the inverter instead of the negative, because the positive is what takes the brunt load. All right, bye-bye.